I have been meaning to show how you actually do computational design in Giraffe for a while. But every time I do, because I'm on staging, I find a bug and I then follow it down so the video is not compelling. So this time I am going to see it through. So just bear with me. We're going to do it live. And I mean, if there's any feedback, I would love to have it. And I'm not starting from zero, I'm starting from something. So what you're seeing on the screen here is a Delaunay mesh triangulation. So the way Delaunay works is it sort of makes these triangles around these points, and then each point has an elevation. So you can see there's like an elevation, and I can go up or down, raise or decrease that number. Not quite as fast as I would like to, but so be it. Now what I thought I would do is add some columns at every point. So you can see this height property gets fed in, and that sets the height of the shell. And then it'd be cool to have a column there. And so I'll add those columns using my techniques, which are not perfect, but are kind of cool. Okay, so here's what's actually happening. And this, I just look how cool this looks. I'm just stoked on the UI. As in the new Giraffe, you just collapse that, and you have this cool 3D window, and you have this text editor, and I can shrink that guy down. It's just so cool. So, and if I click on this, I should be able to see the property there, the height property. Okay, but we want this bad boy. I'm gonna have a sip of my tea. Melbourne breakfast. Okay. So what we did is I needed the Delaunay function, and the Delaunay function is from this GitHub library called Delaunator. So I went to the source code and I just copied the class, and it has one dependency, which is this coord 2D, this orient 2D function. And I just went and I grabbed the minified orient 2D function and I whacked it in, and that's why it just looks so good. This is like fully elite level coding. So then we have the Delaunay function, and we have its dependency, which is this orient 2D. And actually in the Delaunay class, there's a few more functions and some great comments, chitty chat, like this add triangle, pseudo angle, dist, incircle, and all of this stuff, which is written. I think this could be written by Vladimir Agafonkin from Mapbox. Could be. But I think he's getting it and transpiling it from something else. You can sort of read up about it somewhere. But, really cool, very smart code, which I just get. And then all we needed to do, or all I needed to do was, I didn't need this quick sort or this median or anything like this. I wrote a little converter, which takes our Giraffe points and converts them into the kind of array that the Delaunator class wants, which is this kind of flattened array, which is just like x, y, x, y, x, y, x, y, x, y, because it's a geo function. And then I did points 3D, so we also, we got the x, the y, and the item properties.height. So we have a z, because what the Delaunator triangles are is just a set of indices of what, so say this is 0, 1, 2, 3. So there'll be 0, 1, 2, 3 as one triangle, and then 3, 2, 4, whatever, 2, 1, 3 rather. And so it's just an array. So then you pick the point corresponding to the index that's made up by the Delaunator. And so you can always see you're getting the base index plus 1, the base index plus 3, the base plus 2 plus 5. And all of this stuff, right, is created by ChatGPT. So we use the Delaunator to create the Delaunay, and then we use 3 to create these meshes on this Delaunator. Okay, which is really cool. Really cool. So, cool to show. and quite easy to do, as in, you know, the way that I do this is sort of copy paste ChatGPT. So I wanted to show actually how I do that. And so what I'll do is I'm going to grab this function and I'm just going to mark for myself where this function goes. And this is where the work is probably a little bit, my workflow is a little bit undercooked. And there's probably the potential to say, rather than copy pasting and marking and annotating, which I've often sort of catch myself out in bugs, I should do a number of panels and concatenate them together and break out this evaluate JavaScript node. But for this video, let's not do that. Okay, so this is the function that is creating this mesh. And actually what I'm going to give to ChatGPT is I'm going to include this properties.height. You'll see why in a second. So I say, here is my code that makes a shell roof from some points. And those points are called points 3D. Update this code so that it creates a column at every point with bottom radius 0.2 and top radius 0.4 and height set to properties dot height Z. The columns should be white cylinders and should be added to the same group as the roof mesh. Remember to update the group matrix before to JSON. And then I paste the code. And boom, let's see what happens. Okay, now that was a bit, that was silly, right? I meant or Z, but that reads as an expression. Okay, unfortunately nothing's being changed here. Sometimes when we do this, the LLM takes it upon itself to update the function itself. You know, just randomly change it, which is always sad. Now I've also got this green material, which I've got this like, which I'm going to get rid of, but okay. So you can see what it's doing there. It's going column height. So points 3D, it's mapping across, and point 2 is the Z height. So we'll just use that point 2 as the height, as a column height, and we should be good. And it's a material. Oh, you see, so yeah, it's clever. All right, so let's copy that in and just see what's going to happen. And also just let's see, create triangular mesh. So good, it's only updated the create triangular mesh function, which is good. So that's the one that's here between these two bad boys. So I'll paste that in there. And I'm going to get rid of this. Okay, now you can see there are the columns. They are there. They were not updated. Okay, so I think we can just tell it that. The columns are lying on their side, not placed with Z up. Can we rotate them? Also, do we need to update their matrix before adding to group? Okay, so this is another, I'm sort of trying to get my head around this. I know a bit about Three.js, mainly from faffing around with ChatGPT. So I know that this update matrix malarkey, as in 3 doesn't update like this position. You can see this column position is set to 0.0, 0.1, 0.2, but they're all at 0, 0, 0. So there'll be all those columns there. So something's not working. So, but I know that's frequently an update matrix thingo. So at least I can prompt very accurately, but so there is a degree of knowledge that you want. Also, you can see what I was saying. The copy pasting is a little bit. Okay, there we go. We're good. So there you can see that those little bad boys are right there, and we are scaling by Z. There we go. And so we actually want it the other way. Okay, there we go. So now we have kind of flute-shaped columns at every corner of our dude, which is, I think it's pretty amazing. Oh, and you can see I've got my little green guy there. So I'm going to do two things now. First, I'm sick of grabbing everything to get this thing. And secondly, I'm sick of the green. So let's get rid of the green. Const green material. Okay, so we're going to just do this thing and just kill it. Okay, so that should have killed the green without having killed anything. Great, it has. There's like this ugly green cloud. Let's just lower this guy. Okay, that's cool. All right, and now what I want to do is this flow is hosted on one point, which is this point, this read feature node. So what I'm going to do is I am going to add a marker to that point. And so the way I normally do this is you just add a marker, add an icon to the world, and make it a little small, a little bigger than that. Okay, let's go 0.3. Cool. It's slightly too small. Jeez. 0.5. And then what I do is copy the raw marker. There you go. And I literally just copy all of that. And what we're going to do is on the active thing, we're going to write that property. Write property. So to properties dot marker, we're going to write a panel, and that panel is going to be this, and it's just going to be the value, which is this. We're going to do that. And we're going to do this. And ask ourselves, did it work? Reader. Okay, so you can see that we just got a string, right? /n/n, so we didn't get the JSON. So what we need to do is pass this to an actual object. Boink, and boink, and whoop. Okay, and now we have got a paw Okay, yep, so there was actually this. There we go. All right, and you see as soon as I got that right, there is a little tiny marker on the relevant point, which is this one. And it looks cool. It looks like it's part of our design. Okay, so that's good. And I'll delete this marker now. All right, so we are about 15 minutes in and we have done some real computational design, and I want to go the next level, and I want to ask ChatGPT that instead of a single column like this, I want like a trumpet, so it grows. So it's divided into 10 segments that grow. Let's say parabolically, so that the rate, so every time is k times height squared for 10 increments of height up the column. So it's going to have this nice curve. So let's see if we can achieve this. Okay. Now, normally what I'd do here is, you see we made some adjustments. Like, so ChatGPT or the LLM really was into that divide by Z. So the they were putting this divide by Z up there. So we've got our little baby columns, divide by 10. It's like super hard to get it to forget that. So what you do, or what I do, and again, I'm not a prompt engineer, is I just start afresh. This is my code. Update the column. It creates a column with a base of radius 0.2 and a top of radius 0.4. Update it so that it is divided into 10 segments. So it is divided vertically into 10 segmente. The radius, the radii of each segment grow according to k times h squared, where h is the height of the segment. Okay. The top radius of any segment is equal to the bottom radius of the next segment. Okay. The column should grow from 0.2 to 1 according to this parabolic relationship. Okay, let's see what that does. Is that precise? Is that unambiguous enough? Okay. Yeah, cool. It feels like that's roughly close to what I asked. Although I get the feeling it may be, we may get like a ziggurat instead of like a smooth growing. Okay, well that's good. So no, it's doing a radius top and a radius bottom. Group update, is it updating? Okay, so let's just see. I just want to understand where it calls the group update matrix, column update matrix. I think this is wrong. So anyway, let's just see. Okay, so all right, let's just copy this big lump of code and chuck it in here. Now, something that I actually also do is when it's good, we may as well copy the whole thing and just score a copy. So I've just dumped that into a text document off to the side. And then I got to come back here and copy that again. Okay, so yeah, it didn't update the matrix. Hey man, you gotta update the matrix. So just before we group add the segment, we segment.update matrix. So just there. Okay, that's better. Hey. Okay, so with there a little bit, I did tell it needed to rotate them. Column height is not equal to 5. Segment height. Okay, let's just do this. We say const column height equals 0.2, which we know. Okay, that looks better. And then we just need to we need to do this. Okay, that looks better. Hey ho, this is getting cool. Okay. The segments face sideways. Each segment needs to be rotated to face upward. I'm telling you that. I am correct. Now, also, I don't believe that the height is correct. And also, I don't believe that I'm getting the correct. Okay, hang on. So that's just calling that out. So if I delete those two. So I need this bad boy. Because K refers to column height. So if we delete column height, then this fails. So let's get K in here. So it's, in the closure. Looks better already. And then I think we can delete all of these silly fellas. Yeah, we're still good. Well, you see, this is the problem. Once you start coding and then chat's coding as well. Oh dear, but I think it's just this. Cast shadow, receive shadow. Yep, so we do this. Oh my. That looks luscious. So now we just have one problem, which is that it is too tall. So what is current height? Car. I think if we just do, what if we just did this? Minus column height. Yeah. Yep. Don't know where you got added. That is absolutely stunning. Okay. Oh man. Okay, let's do 2, and we will just column height, and we'll say minus 0.5. Does that work? Okay, so that doesn't work. But it doesn't fail. That's oh, no, it's growing from the bottom. So minus 1. And this is real hack. This is real hack. Yeah. So I'm just not understanding the full transformations here, and so I'm adding and subtracting in a linear way. I actually want that to be 0.3, and then that has to be 0.3 as well. We should parameterize that, but and I want this to be about 1.2. Oh, that looks great. Okay. Now, do we want them white? Something feels wrong. So if it's super short, oh no, it's good. Man. Okay. Let us add a. Let us add a. I want to try and add up an outline. Okay, and I'll stop at 30 minutes because I'm definitely boring you. Okay, so let's go find the outline, and if I search for outline, there's somewhere in here we create a new outline mesh, wireframe mesh. Which is in here. Okay, so I'm just going to copy that and paste it. Seg, wireframe mesh. Nope. So this segment, rotation. So this segment is a new 3-dot mesh And then the seg wireframe mesh is a new 3-dot mesh, same geometry with the wireframe material instead of the column material. Now wireframe material is defined inside of the mega function, so I think we have access to it. We scale it. And we're going to do this group dot add seg wire frame mesh. And you see there it is. And so what we need to do is we need to do this seg wireframe mesh dot update matrix. Why are you not there? Oh, because I need to do this whole thing. No. Sorry, silly. So everything you do to the segment, you need to do to the seg wireframe mesh. So copy, paste, paste. Groovy. Oh. Wow. Whoa. So I think we can do this here and say, let's do 12. Let's do 9. Let's do 5. Cool. It's very meshy. It's very wiry, isn't it? It looks a bit like a stockinged leg, which is not what I was going for. It looks a bit silly, doesn't it? So I wonder if we now... Cool. All right, I may do this. We do this, we're using this wireframe material. We do this. I'll paste it here, and I'll say seg wire. It'll be seg wire. See, this is why it's better to use the GPT, isn't it? Because it's just so much faster. And I want it to be gray, so EC, EC, EC. Too light. What about not F, not F, not F? Too dark. Let's go to 3F, 3F, 3F. Yeah, just right. This 5, 9. Okay, so what have we achieved? Computational design. We have computationally defined a fluted column that is parameterized by height, as well as top radius and bottom radius, as well as segments, as well as, there's a lot of parameters here, sort of segments in the vertical and segments in the horizontal. And we've attached to every point. And now we have like a little shell making thing that has these stockinged legs, and it is quite heavy. You can see the graphics card is starting to you see that's starting to struggle on the updates. No, friend. So there may be some draw calls that are, able to be optimized here. I think there's quite a lot of update matrix world going on. But I just think this is a really fun way of doing computational design. And the idea here is these are sort of pavilions in the, this is the program in the, under a single roof. That's the building.